The first question was how many sides has a regular polygon which has each interior angle 135 degree. We already know that the sum of each interior angle in any polygon can be written as n minus 2 into 180 degree. But in the case of regular polygon, each angle should be equal. So if we divide this expression by n, we can get each interior angle. And there is given each interior angle is 135 degree. So this expression should be equal to 135 degree. Now this is a question of linear equation. We can solve it simply. So it will be n minus 2 180 degree equal 135 degree n by transferring n. Now just simplify. 180 n minus 360 degree equal 135 degree n. Collect like terms, so 180 so 180 n minus 135 n equal 360. 180 minus 135 45 n equal 360. To get the value of n, we need to divide by 45 both sides, so it will be 360 by 45. After simplifying by 9, it will be 9 5 is 45, 9 4 is 36, and further simplifying by 5 5 1 is 5, 5 8 is 45, 5 8 is 40, so it will be n equal 8. And on the basis of this number, we can write the name of that polygon, which is octagon. And this was your second part of this question, as write the name of the polygon. So name of that polygon, octagon. Second question, name two polygon whose diagonals there are two quotient a and b. In both question we are required name of two polygon. So in the case of first, diagonals bisect each other at 90 degree. Diagonals bisect at 90 degree. So we know the first figure is a square and the second figure rhombus. In both cases, diagonals bisect each other at 90 degree. And in the second question, diagonals are equal. Diagonals are only equal when figure is straight. Straight means each angle is 90 degree, and there is only two polygon. The first is rectangle and the second is square. So these are the answers. In the third question, how many diagonals are there in a hexagon? You can simply count it by just making a hexagon. 1 2 3 4 5 6. From this point we cannot draw a diagonal to that vertex, and again also we cannot draw a diagonal at this vertex. So for this point we cannot draw diagonals by matching 1 2 3 vertex. So there are how many diagonals can be drawn from this point? Total 6 vertex and minus 1, so we can draw only three diagonals from this point. Again from this point we can again count. We cannot draw this vertex and this vertex and also this, so also three diagonals. But at this point we cannot draw another diagonals, that is this, because this diagonals has already been drawn. So at this point we can draw only two diagonals. As you can see, 1 2 3. At the second, 1 2 3. At the third point we can only draw two diagonals, 1 and 2, because third diagonal has already been drawn, so 2. And from the next only 1, and from the next 3 diagonals has been drawn. So the total value 3, 3, 2, 1. Just add this 3, 3, 6 and 3, 9. So you can answer this as 9. There is also a formula which can be used to count the diagonals, but I didn't told you because you have already too much formula in your book, so you don't need to use more formula. If you have any practical way to calculate or to count anything, you can use a formula n minus 3 upon 2, and this formula can be deduct this formula can be deducted using this logic, because 3 numbers are natural and another number is repeating the last number. So this formula can be deducted by using the formula. Put the value of n, that is 6. So 6 into 6 minus 3, 3 upon 2. So it will be 9 diagonals. By any method, your answer is correct. A regular polygon has 15 sides. Find sum of its all interior angle. We have already discussed about the formula in the first question. So sum of its all interior angle, it will be n minus 2 into 180. Just put the value of n, 15 minus 2 into 180. It will be 13 into 180. (2340°). In the second question, measure of each interior angle. It can be calculated by dividing the total angle by number of angles, which is 15. So 2340 divided by 15, and it will be 156°. And the next question, measure of each exterior angle. Measure of each exterior angle, we already know that the sum of each exterior angle, sum of all exterior angle of any regular polygon, any regular or irregular, any polygon is equal to 360°. And if sum of all exterior angle is 360° and there are 15 exterior angles, so just divide to get the value. So it will be 15 to the 30 and 15 for the 60, 24° is the each exterior angle. The next question, question number 5, write the sum of all exterior angle of a polygon which has 19 sides. There is no any matter of the number of sides. We already know the sum of all exterior angle of any polygon should be equal to 360°. So the answer of question 5, it will be 360°. Question 6, the diagonal of rectangle ABCD, the diagonal of rectangle ABCD intersect at O. A, B, C, D diagonals are intersecting at O. If angle DOC, this angle is equal to 40°, then find ABO. ABO, this point is O, and ABO, it means this angle has been required, this angle. Because this is a rectangle, we know that opposite sides is parallel, and if both sides is parallel, we know that vertically opposite angles are equal. So if this angle is 40°, this angle should also be equal to 40°. And we know that diagonals are equal. If diagonals are equal, and we already know that diagonals bisect each other, it means if diagonals are equal, so half of that diagonal should be equal, because AC equal BD. So by dividing 2 on the both side, we get AC upon 2 equal OA. AC upon 2, that is OA, and BD upon A, BO. So now consider this statement that OA equal BO, we can consider in the triangle that these two sides are equal, and if these two sides are equal, then triangle is isosceles triangle and opposite angle should be equal. So if this angle is x, this also should be x. So using the angle sum property in this triangle, we get x plus 40 degree equal 180 degree. Now you can solve this linear equation to get the required value. It will be 2x equal 180 minus 40 degree. It will be 140 degree. So the value of 2x 180 degree, so 140 degree, so x equals 70 degree. That's the required answer. In the next question, ABCD is a rectangle in which DP and BQ are perpendicular from diagonal AC. BQ and DP. BQ and DP are perpendicular. These lines are perpendicular. It means this angle should be 90 degree. Prove that triangle ADP and CBQ are congruent. It means we need to prove this triangle and this triangle to be congruent. How many things are equal in both triangle? Just observing. The first thing is that angle 90 degree, and the second thing, because the given quadrilateral is rectangle, so opposite sides should be same. So this side is also equal. We have two things equal. On the basis of these two, we can try for congruent criteria. Congruent criteria related to these information as one side and one angle. We can use either side angle side or angle side angle. In both cases, we need either one angle or one side. We don't have any logic to equal these two sides, and also we don't have any logic to equal these sides. So we need to work on angles. The first angle is created by this perpendicular line, and we do not have any information. But one information about this angle, that is because of parallel line. We have already given that the given figure is a rectangle, and we know rectangle is also a parallelogram, so opposite sides should be parallel. If line AD parallel to DC and line AC is transversal line, in that case angle DAP and angle DCQ should be equal. Now in both triangle we can see that one angle, second angle and one side is equal. So this is the criteria AAS, because our equal side is not between the both angle, so this is not ASA, this is angle side. So using AAS criteria, both triangle are congruent. This is all the questions which are asked in the test.